Okay, I think now I get started. So this session is to revisit some issues around statistical analysis. So when I communicate with some investigator, I get some common questions. And I try to address these questions or issues at these sessions. And about the date and time, we usually have, well, second Thursday at 2 o'clock, and sometimes we may finish early at 2:30, or we may finish later depending on the topic. And the detailed calendar you can see in Salurba team calendar, or next slide, which I'm going to show, or Google Drive, which is mentioned here. And I'm going to use this my office hour time for data management analysis. So if you plan to come to my office hour for this week, please contact me for the arrangement. And about the Zoom link, it's going to be different next time from August. So please keep in your mind. And this, this address is also, you can find this address in Salurba calendar and in the Google Drive, in the material which you can find in Google Drive. And the style is, I'm going to do presentation which is about for 15 to 20 minutes. And if you have questions, please interrupt me in the middle. You don't have to wait up to the end, or I get some questions after the session. So feel free. And presentation slide and recording will be posted on the sessions Google Drive. And for example, I'm going to do this. So it says a Google Drive for this session, and you'll be able to see the schedule I was mentioning and other things in this Word document. And also I'm going to post all the materials and recording I use here in the folder. Okay, go back to the slide. And if you have any questions or suggestions, please contact me. And this is a schedule. So today I'm going to talk about this mix effect on GE modeling, and next week I'm going to touch on EDA, exploratory data analysis with cluster data before we plan modeling, or so that we can model the data better. And from September, these are dates, but topics are not decided yet. And there are some topics which were covered at live event study group meeting, which are about how to decide the model for count data, Poisson model, negative binomial model. And another topic we touched was log transformation, when we should consider, and how we should select the appropriate logarithmic function, and interpretation of such variables. And these slides are also found at Google Drive I mentioned previously. And these are topics in my mind in the following sessions, but again, please give me any suggestion about topics we should handle. And I wonder if you have any questions up to now. Okay, let's go on. And well, so today's session, okay, and today's session, well, before we go to the main topic, which is about the modeling approach between mixed model and GE model, we are going to do some recap about notation used for analysis of correlated data, and also some issues surrounded by this in data analysis of correlation data before we go on to this modeling issue. And well, this is a data set, example of the data set. In this example, we have data of individual people measured at different time point from 1 to 6 who belong to households from different cities. And the data set is going to be like this. One row represent data of one individual of one time point who belong to household 1 and city 1 in case of the first row. And this person provided 2 records, time 1 and time 2. And the second person in the same household provided 3 time points, 1 to 3, and then go to the next household. In next household, there was only one person, and we have only 2 data points, time point 1 and time point 3, something like that. Then to describe this data set, we usually use notation, which sometimes confuse us. And with this example, I use notation I, J, K, T, which represent city, household, person, and time. And in this data set, we have data of I cities, well, city 1, city 2, up to city I. And household, we have, well, household 1, household 2, up to JI household. Here you see small I here because the number of household differs depending on the city. When some cities may have more household and some cities have a smaller number of household. And this is the reason why you see JI here. And similarly for person, we have, well, here person 1, person 2, up to K, IJ. And here you see small subscript IJ because the number of person in the household depends on the household. Some households may have bigger family and some households may have smaller families. And time T equal 1 to up to TIJK, and also the number of time points varies depending on the persons. Some person may contribute more time point and some person may contribute less time point. Then we use this notation, and when you see manuscript which talks about with a cluster data set, you see this small subscript as using the subscript I mentioned, like I, J, K, T. By the way, here, for the notation, sometimes we use this notation starting from I, but sometimes people use, well, first letter of each variable, like C for city, H for household, P for person, and T for time, for example. Also, in my case, I use I for the highest level of the observation, but sometimes people may use in opposite way. Sometimes I stands for smallest unit. And here, Y stands for response or outcome variable. But what does this IJKT mean? Well, it means response or outcome value of the person at person K at time point T who live in household J in city I. This is the meaning of it. And the same thing, and we use X to mean predictor or covariate. And the meaning of IJKT, they're the same as I explained for Y. And sometimes for covariate, you may see this type of thing. So we have XIJK, but T is missing. But this means that covariate or predictor is time irrelevant. Like a person's sex or race, they don't change even if they get older. For this reason, we don't use T here to be specific on this. And Xij, this means that this is a variable which is household specific. So people who live in the same household share the same value, like well, household, well, having electricity or having water or longitude, latitude, something like that. And finally, xi, we may use xi to specify predictor covariate, which is specific to city. Like I should say, mean temperature for city I, for example, longitude, latitude, something like that. And well, so this is a multi-level data, as you can see. But when we have this time component, or when we have repeated measurement for specific individual or specific cities, we call the data longitudinal data. And do you have any question about notation? No? Okay, then next one. So now, so what is a issue? What we have to be careful when we use correlated data? So one important assumption in many statistical tests and regression analysis is this one. Data are uncorrelated or responses are independent. What does it mean for uncorrelated or independent? Okay, my blood pressure is, well, systolic blood pressure is 120. And my friend Hordan, what is his blood pressure? I mean, his blood pressure is not related with mine, right? He's different person, and then can we predict Hordan's blood pressure if we know my blood pressure? No. So this means that our data are independent. But for example, but we got to know that, well, Hordan and Gora, we live in the same house, sharing the rent, and at the same time sharing food as well. And we have tendency to eat papa frita after eating, and then maybe we may have higher blood pressure as compared to others. And in this case, we have clustered data sets. Okay. And so what is a problem when we do data analysis of correlated data as if they are not correlated? Usually, the point estimate was the difference in associations or odds ratio or relative risk. They are usually not affected much. But the problem is this one, variance estimation is going to be affected a lot. So if the variance is affected, what does it mean? It's going to affect our standard error. It means that our confidence interval is going to be affected, as well as p-value. So this is a problem. So depending on the situation, you may fail to detect association, although there is an association. Okay, that's too bad. You had a power to detect association, but you didn't account for clustering, and you are saying that there was no association. But opposite thing can happen as well. You may falsely declare association. There is no association, but you are saying that, hey, I found associations that are significant, which is also a bad thing. So this is the reason why when we have correlated data, we have to account for this correlation. And here are some examples of tests with independent assumption, like two-sample t-test or ANOVA, chi-square test, regression analysis ignoring data correlation. These are examples of statistical test or regression which ignore correlation data, which we should not do. And so what to do when we do regression analysis and when we want to manage correlated data? There are basically two approaches. One is called marginal or population averaged model. And I gave 3 examples below this modeling approach, and commonly used is this this approach called GE. generalized estimated equation. And conditional and subject-specific model, we tend to use this mixed effect model. There are two approaches basically. And I think in Saddlebar, we usually use mixed effect model or conditional model as compared to marginal model in general. But we can use either approach. So now let's talk about with the difference for these approaches of these two modeling approaches using some example. So first one is about longitudinal analysis. And in this scenario, we measured systolic blood pressure of 2 persons. And we followed these 2 persons for 10 years. And our final goal is to estimate an overall change in systolic blood pressure over time. Well, the line you can see in this graph. This is our final goal and what to do. And now the question is, the data are correlated or not? Yes, they are correlated. As you can see, as we can imagine, if the person one, the first blood pressure measurement was 130, and then we expect, after 1 year, we are going to measure blood pressure again. And we expect that, the next blood pressure is going to be somehow close to 130, right? It's not random. And then we go on, and then the blood pressure of person one is somehow correlated because it belongs to the same person. So we need to consider correlation, and we do what we call longitudinal analysis. And how these two approaches, GE and mixed model, handle these two scenarios. So in GE model, so we try to find out what is our average trend using this equation. Systolic blood pressure of person I at time t. My cursor disappeared. Okay, I'm here. Is given by beta naught for intercept at time 0 for value of systolic blood pressure time 0 plus beta 1, which is a slope, times year, plus error term, which is specific to person and time. And this line, this is the line what we wanted to get, is given by this equation. Systolic blood pressure dot t, dot mean or average. Overall mean at time t is given by beta naught, this value, plus beta 1 times year. And beta 1 is an average increase in blood pressure by 1 year. Right? So the difference between this one, the equation I was talking about, and this line is if we have this error term or not. And actually, this equation is the same as when we model the data without considering correlation, actually. So what is the difference? And the difference comes in next. So now we look at the residuals. Residual is a difference between fitted value and observed value. So here, this first red line shows, which is E10, which means a difference between fitted value and observed value for person 1 at time 0. Okay. And then when we move to this blue one, E20, this means the difference between fitted value and observed value for person 2 at time 0. Okay. And then E10 up to E110. So E110 means what is the difference between fitted value and observed value for person I at time 10, and so on. Then here is a difference from usual regression model. Well, variance of this error term is given by this sigma square, which is the same as usual regression model. But here the difference comes in the next one. This is a correlation of two error terms of the same individual. Here you see EIT and EIT prime. So I is the same, meaning that there is a correlation between residual of the same person. As you can see, these are red one. These are always positive, and blue ones, they are always negative. They are correlated, and we assume that they are correlated. We assume specific correlation term here. And in usual regression model, we assume that this is 0. But in GE model, we assume that this is something different from 0. So this is the difference between GE and usual regression model. And sometimes you might heard this term: exchangeable, compound symmetry, autoregressive, toplets, or unstructured. These are name of correlation structure we assume in GE model. Well, today we are not going through what are the difference between these different correlation structures, but depending on how we assume the correlation, we use different correlation structures. Or for example, in exchangeable compound symmetry, we assume that the correlation between first residual and second residual, first and second, first and third, first and tenth, they all follow the same variance. This is the meaning of exchangeable or compound symmetry. But sometimes you may think that was a correlation between first and second, for time 0 and time 1, time 1, time 2, they may be more correlated as compared to time 0 and time 10 because they are far apart in time. So in this case, you may use a different correlation structure like autoregressive. And now, so how about now mixed effect model? So in mixed effect model, we also want to estimate overall mean. But at the same time, with this approach, we also fit model specifically for the subject. By the way, in this case, we are going to use random intercept and random slope model, meaning that the intercept is different by individuals, as well as a trend. Well, trend for how much systolic blood pressure increases by year differs by person. So if we use random intercept model, the slope for individuals, they are going to be the same. They are going to be parallel. But in this case, we are going to use slope model because the trend seems different. Then, what is the equation? So it sounds a little bit complicated as compared to GE model. Let's go. Systolic blood pressure of individual I at T is given by beta naught I, here you see small I here, plus beta 1 I times plus error term. So the difference, what is the difference between GE model and random intercept, which is this a small subscript I. So now I stands for each individual. So we have individually or subject specific intercept and time. This is the meaning of it. And beta naught I can be expressed as beta 0, which is a mean value across individual, plus a difference between mean value and intercept of that subject. And similarly for the slope, beta 1, which is a average slope across individual, plus the difference in slope for specific individual I times year and plus error term. So we can write in this way. And also we assume that this B0, B not I and B1I follows normally follow a normal distribution with specific residual. Although we cannot, it can be other distribution, but we tend to use normal distribution for convenience. And also we assume that there is a correlation between B0I, B not I, and B1I. And here I want to mention, we use different statistical packages. And for example, Stata assume that this correlation between random components is 0. Okay, it's a default. So if you want to specify correlate, if you assume that there is a correlation, you have to set an option. You have to use additional option for Stata. But if you use R, this is a standard. And if you want to assume that correlation is 0 among random components, you have to specify that I assume the correlation is 0. Okay, so it's very important that you write down your equation, translating your syntax you use for your analysis to this equation, so that you make sure that you know what you're doing. Okay. Then I may repeat a little bit, but this line, the first line, this is a subject 1 specific line, is given by, as I mentioned, beta naught plus beta naught 1. So this is a, so this is beta naught, and the difference from here to here, this is given by B0, 1, right? So this is an intercept for subject 1. This value is given by beta naught plus B0, 1. And then his slope is given by this. So the slope for this population mean is given by, so by 1 unit, the increase is beta 1. But the increase of SBP for person I is a bit more than mean value, and which is given by per year beta 1 plus B0, 1. Right? And similarly for person 2, this line is given by this equation. So this part is common, but this one, B02 and B12, this is subject specific. Okay. Then I'm going to erase the one I wrote because it's a bit difficult to see. And the mean one, mean of overall mean is given by SBP dot T is given by beta naught plus beta 1 year, which is the same formula as GE model. And next, how about residual? Residual is a difference between fitted value and observed value, but now you see the difference between GE and mixed model. The difference between observed and fitted, but fitted using the line for subject mean. And here, by having subject specific line, we assume that correlation is, well, there is a typo, and this should be, sorry. So this is the equation. So error term, we assume the variance of error term is constant, although we can make it different, but in standard mixed model, we assume that they're constant. And here, by having subject-specific slope, the correlation between residual becomes 0. This is what we assume. Again, well, in standard, usual mixed model, we can still make a model where these residual are correlated still. But in many cases, we assume that they are 0. Do you have any question up to now? No? So let's go.
Hi, Guru. Yes, I have a question.
Hi, Nancy.
Please, hi. Do you have some examples in which the errors are correlated or could be correlated?
Possible. It's possible, meaning that, well, here we use random intercept and random slope, meaning intercept and slope, they are subject dependent, but still it may be not sufficient. And then we may have to assume that there is correlation still, although the model is going to be complex but well, going back to your question, I cannot give you specific example, but there might be such cases.
Thank you, Guru.
And ask for statistician for help. And then in the next session, we are going to talk about this exploratory data analysis, which include this assessment of residual about correlation. And then that one give you which model you have to use. You can use only random intercept model, or you have to include slope as well, or you may have to consider correlation between residual after you include intercept and slope as well. So now we go to multi-level analysis, which we do more commonly in Sarurubar. But unfortunately, this example is not about health, about education. So we have teaching program A and B. We want to know the difference in these two teaching programs, and we measure, and we want to assess these two programs using the test score by students. Okay. And our final goal, well, and then two schools participate in this study. And the final goal is we want to know the difference between program A, program B in terms of test score. And by the way, these are individual. These dots show the score of each student. Okay. And when we look at this graph, you got to know that in both program A and program B, students in school 2 tend to have higher score as compared to school 1. Maybe because of some demographic factors, or maybe because of school factors, I mean, teachers' qualification or teaching material, etc., which are not affected by the program. But anyway, this means that the data are somehow correlated at school. So we have to account for it to do correct analysis, and we do conduct what we call multi-level analysis. And again, there are two ways to do GEE, using GEE or mixed model. So using GEE model, well, we try to measure, we try to estimate what is the average score among program A and program B using this model given by this equation. Well, score of student J in school I is given by beta naught, which is a mean score of program A, plus beta 1 times program, assuming that program is an indicator variable for program B. So B1 shows a difference between program A and program B. Okay? And up to here, there is no difference between model which consider correlation and which doesn't consider correlation. Well, and the population mean is given by this equation, and only the difference between these two equations is if we have error term or not. And then next we look at the residual, which is the difference between fitted and observed, which are represented by this blue line. And as you can see, for school, well, look at this blue line in school 1 and school 2. And you notice that in many cases, school 1, the residual school 1 is more negative as compared to school 2, which we have more positive residual. So in GEE model, we assume that there is a correlation if students belong to the same school. So here you see correlation EIJ and EIJ prime, meaning there are two, well, we are comparing residual of two students in the same school I, okay? And then we assume that it's correlated and given by this correlation correlation index. And if we do analysis using regular regression model, our assumption is correlation is 0. But when we use GE model, we assume that this is different from 0. Okay. And how about if we use mixed model? Well, mixed model in the same way, similarly, we estimate mean score for program A and program B, as well as we also estimate school-specific mean for program A at school 1 and school 2, as well as mean test score at school 1 in program B and school 2 in program B. And the equation is like this one. Score of student J in school I is given by beta naught I. So here is the difference. You see small subscript I plus beta 1, which is not school specific, times program, plus error term. And this beta naught I can be expanded as follows: beta naught plus B01. So for example, this is a expected mean from school 1 in program A and program B, which is given by score I dot, meaning test score of student who are in school 1, dot mean across students, is given by beta naught, which is this one, plus B naught I, which is a difference between overall mean and school mean, plus constant effect of program. And in case of program, we assume the program is an indicator variable for program B. So if the students are program A, this term disappears. And this B naught plus beta naught plus B01 is the test score for school 1 in program A. And this test score in program B is given by the same quantity plus expected difference by program, which is beta 1. And similarly, we get school mean equation for school 2, and we get also equation for overall mean. And now how about residual? Residual, what is it? Which is the difference between observed and fitted. And here you see the difference between GEE and random effect model. And this blue line, now it seems that they are scattered around along school mean. So in this model, we assume that by using school-specific intercept, now the correlation between students become 0. So this is what we assume in this example or using random intercept model. And do you have any question up to now? No, silence. So the next question is, well, I presented GEE model and the other is mixed model. And then the next question is, so which one we should use? This is the next question. And the answer is, it depends, as usual. And mixed effect model is called conditional model or subject-specific model for the reason that we also get equations specific to each subject or each city or something like that. And GE model is called marginal or population average model when we want to see the association in the population. So first thing you have to think about is, do we want, well, so the interpretation of coefficient is going to be different. And fixed effect parameters show average subject specific effect in using mixed effect model. And we get a coefficient of fixed effect in G model show population average effect. But you may ask question, what is the difference between them? So it's like, well, you can think about in this way. For example, say we want to know the probability of having heart attack of certain people. And now you are a physician, you are in front of the patient, and you know there are several factors that affect heart attack, like hypertension, hyperlipidemia, etc., etc. And you want to know what is the probability of this patient having heart attack, say next year. So in this case, you are interested in individual, and you want to know the effect of each factors on individual. But on the other hand, now you are working for Ministry of Health, and you want to find out the intervention for heart attack, and you know the associated factor, as I mentioned, hypertension, etc. But this time, since you want to do intervention at population level, and you want to know the association between outcome, which is a probability of having heart attack, and associated factor at population level. So this is how you may use different approach differently depending on your study hypothesis. And the second thing is this one. Well, sometimes you are interested in variance decomposition, where you see the variability across individual or across cities, and you want to know or you want to decompose if this variability coming from between subject variability or within subject variability, or in some cases you use what we call ICC to calculate it. And if this is something you want, you may use mixed model instead of GEE model. Okay? And mixed model, we can handle multiple levels, but with GEE, we can handle only one level. And there are some differences. I noted two things, and there are more pros and cons between these two models. And what I personally do is as follows. Well, first of all, I look at these two components. What kind of estimation we want to get? I want to get individual level or population level, or it doesn't matter. And the second thing, And do I want to model this multiple layer of clustering or not? Or do I want to do I want to calculate ICC or not? And then if they are similar, I usually run two models. One cell for main analysis and the other cell for sensitivity analysis. And this is what I do. And the additional information. If you use a linear regression, the estimate you get from mixed model and GE, they should be the same or very similar. Or if you use Poisson model, similar thing. But when you use logistic regression, the estimate by mixed effect model is higher as compared to GE. Well, I'm talking about here odds ratio, but when you look at p-value, they should be similar. This is what we expect using these two models. But anyway, this is what I do. Okay. Then do you have any question up to now? Okay. Then here's.
I have actually. Do you know how these methods compare when you're just trying to estimate the average effect? Can you go back to one slide, please? Because when you have a mixed model, the overall mean, you usually estimate it as a sort of a prediction, right? I mean, it's a sample average of the random intercepts and the random slopes with the covariates you have. So I've never seen anyone comment about this, but I think that if you're just interested in the overall mean or the population mean, I think that the GE might be more efficient, more stable, or
Yeah, good question. And also I want to ask you, Lee, since you're a statistician. I think it's, and I think theoretically, well, if we use a linear regression model, both of them give us the same answer. And in terms of standard error, maybe GE model may be more efficient, maybe, but we don't have perfect data set. I mean, some of them are unbalanced, and we have data set with different number of observation in each clusters, and missingness may exist in the data set. So I'm not sure. And I wonder really if you have any answer for that. Well, sorry for questioning back to you. And if anybody have any experience with this, please let us know.
No idea.
it's because it has already happened that, for example, you want to report as a part of a descriptive analysis, sort of a population or overall mean. And I've already did this with mixed effects models, and some of reviewers and referees didn't like it very much. So like, that's no, you shouldn't use the output from a mixed model to compute this. Just do linear regression or a GE, but qualitatively, I've got the same results. I'm not sure. I suspect that it might be more efficient doing just GEG just for this purpose, but I really don't know.
Yeah,
it's more parsimonic, no?
So yeah, it's a I cannot tell either. Sorry for that. And also, which we use GE model, random intercept, well, GE model or mixed model, like I should say, there are many cases where we can use either, both of them. And in some scenario, sometimes we can say, well, you should use mixed model or you should use GE model because of your hypothesis and because of the nature of your data set. but sometimes we cannot. At the same time, and unfortunately, there is also preference by data analysts and also in the field as well, like social scientists, like when people are working in education, they tend to use mixed effect model much more as compared to GEE. And in some model, in some area, well, people tend to use GEE as compared to mixed model without how to say statistical reasoning, but because of history. Well, people usually use GEE, so we use GEE, or people tend to use mixed model, so we use mixed model. So, and also it depending on sometimes reviewers, if they prefer GEE, they may say you should use GEE, and sometimes you may got the opposite opposite comments. But I think as you did, to do analysis using two methods and they say what was the result as a reply to the author, not to the author, to the reviewers. And if you have any specific reason why you chose one model as compared to others, you may want to include that one in your reply.
Yeah, it sounds good.
Yeah, thank you, Uriel. And if
Thanks.
you get answer, please let us know. It's going to be helpful.
Yeah, sure. Thanks.
Any more questions? Okay, let's go to the next. So these are differences. Well, these are differences I thought might be useful, but anyway, the first one, I saw that this article shows what is a consequence. Well, I didn't explain a lot, but what is a consequence when you don't consider correlation? And then I think they describe with example nicely. And about the equation for mixed effect model, I saw that this side explained quite good using only one page, but telling you everything using less mathematical terms. So this should be useful. And if you are in doubt, which you should use, mixed or GE model, these are some articles that talk about it. The first one, well, when you want to know, first one shows what is the interpretation of coefficient when you use logistic regression model with GEE or mixed model. And the last three, the remaining three, that compares what are the difference and pros and cons between mixed and GE modeling. And the last two, they are very, they use a lot of formula, but they show some tables which compare two models, so which may be useful for you if you are in doubt in comparing these two. But there are many articles talk about which is better, GE or mixed effect model. And then next topic is going to be how to do EDA, exploratory data analysis, when we do data analysis using clustered data, and so that we can fit better model that fit well with your study design and your data. And as I mentioned, well, next date is August 12th at the same time, and the Zoom link is going to be different from today, so be careful. And I'm going to post this material in the Google Drive as well as in the Saddlebag calendar. So please go ahead, please refer to this material to find out the Zoom link. And thank you very much. And this is the end of my presentation. And I wonder if you have any questions.
Hi, Goro. Me, Rosemary.
Hello, Rosemary.
Hi, Goro. Thank you for your presentation. I have, Goro, do you have an example about the interpretation of the coefficients from GE models and mixed models?
Okay, good. interpretation. And do you have
The
specific model like linear model or logistic regression? Or you want to have some reference?
Okay, and the interpretation of the coefficients resulting from a G model is the same that the interpretation of the I know that in G model, we are modeling the average of the population.
Yep.
And in the mixed model, we are modeling the individual.
Yeah, exactly.
But the interpretation, for example, odds ratio is the same. How do we need to do the interpretation in this
So
in this case?
There is a difference between them. Say it is an odds ratio. Odds ratio. What shall we say? Well, say I use example of previously probability of heart attack. Say now we change to odds ratio of heart attack. So if we use GEE, we are looking at association. Say now we are looking at the effect of hypertension and odds of having heart attack next year. And the interpretation of odds ratio is with GEE, we are getting odds ratio we expect to see comparing two populations, hypersensitive population versus non-hypertensive or normal population. This is what we see in GE, but we use mixed model, and assuming that your data set is at individual level, you are getting odds ratio of having heart attack in 1 year comparing two similar individuals, but who are different in terms of hypertension, hypertensive versus non-hypertensive. So this is a difference between two.
Okay, Goro, thank you very much.
You're welcome. Do you have any questions?
Hi, Goro. This is Valesca. Thank you so much for your presentation. It's so didactic. I do have a question here because I'm trying to figure out. You said, I'm not sure if it's correct. You said that when you using logistic regression, when you use GE, use mixed effect model, the odds ratio tends to be higher than when you use GE. Could you comment on that? I'm trying to understand why.
That's a good question, though. And I'm not sure if I can answer to that question very well, but I try.
Yeah,
and if I'm not able to, I try to find out material which explain well. So can you, well, my screen has changed now. It's like this one. Say we are talking about factor X and the outcome is, we use logistic regression. So our outcome is probability of something, right? And then when we fit the model, for person one, the estimated fitted value or subject specific fitted value is going to be like this, or sigmoid curve. Or if you get confused, well, we take logit of probability so that we can get a straight line, something like that. So because we have different Y scale, we have different shape of curve, fitted value. Okay. This is for subject one. And for subject two, we get this type of sigmoid curve, or this type of one. And for subject three, we have this one. and for slope this one. And now, what we estimate using mixed model, we are estimating this slope or this curve. And when we use GE, it's going to be average of them. So it's going to be something like this. And for this one, something like this one. So the slope become dull by taking population average. And this is the reason why when you see effect is lower in GE as compared to mixed model. I'm not sure if this is somehow understandable, but I try to find out something which is more crystal clear. Why?
Very good. Thank you.
Welcome.
Thanks. Very helpful.
Do you have any other question? Okay, so I think there is no further question, I think. So I think this is the end of this session, and thank you very much for being with me. And today was a little bit long because of the subject and was the topics I covered, but next time it's going to be could be shorter than today's session. And thank you very much for listening. And if you have any suggestion about topics or questions that came up but you couldn't ask today, please let me know by email. And thank you very much.
Thank you, Goro.
Thank you.
Bye.
Bye.
Thank you.
Thank you. Bye bye.
Thanks.